Which do you think will fall faster, a pen or a book?
They'll fall at the same time because of air resistance.
Oh, wait. Okay, so why do you think so?
Because without air resistance, everything would fall at the same time. If you drop like a piece of paper and a brick, it'll hit the ground at the same time. Because without air resistance, they'll hit the ground at the same time. Because everything on the Earth is 9.8. So yeah.
Okay, so will an object with more mass have more or less inertia?
It'll have more inertia.
Okay. Okay. Why do you think so?
Because it's heavier.
Okay. Will an object with more mass have more or less inertia?
Weight leading to more gravitational pull on it, which causes it to fall faster.
Okay. Will an object with more mass have more or less inertia?
More.
Okay. What do you think will fall faster, a pen or a book?
A book,
Okay. Why do you think so?
because the book is heavier than the pen.
Will an object with more mass have more or less inertia?
More inertia.
Okay, thank you. Okay, which do you think will fall faster, a pen or a textbook?
They will fall at the same time
Okay, why do you think so?
because Newton's law says so.
Okay, will an object with more mass have more or less inertia?
More mass equals more inertia.
Okay, thank you. Okay, which do you think will fall faster, a pen or a textbook?
Pen or a textbook? I think it'll fall at the same time because acceleration will be the same for both objects.
Okay, will an object with more mass have more or less inertia?
More mass would be more inertia, I think.
Okay, which do you think will fall faster, a pen or a textbook?
A textbook
Why do you think so?
because it has more mass.
Okay, will an object with more mass have more or less inertia?
More inertia or wait, less? I guess I don't know.
Okay, which do you think will fall faster, a pen or a book?
Book.
Okay, why do you think that?
It's bigger.
Okay, which object will have more mass? Which object with more mass will have less or more inertia?
Wait, what? Object with more mass has more inertia, right?
Yeah.
Yeah.
So which object do you think will have more inertia?
The book.
Okay. Okay. Which do you think will fall faster, a pen or a book? Okay. Oh, why do you think that?
Because the pen it's kind of smaller and it has more weight, but a book it's heavier, so it's probably gonna drop a little bit, probably slowly.
Okay. Will the object with more mass have more or less inertia?
Less.
Okay. And which do you think will fall faster, a pen or a book?
A pen or a book?
Yeah.
Well, they will have the same acceleration, but a book will fall faster.
Okay. Okay, you explained it. Okay, so will the object with more mass have more or less inertia?
Will an object with more mass?
Yeah, will it have less or more inertia?
More.
Okay, thank you. Okay, so the question for our experiment is, will two objects with different mass fall to the ground at the same speed? We predict that the pen will fall faster. For the materials, we will need a scale, pen, and a textbook.
Our procedure is as follows. Number 1, measure your pen and textbook to find the mass. 2, have one person hold the pen and one person hold the textbook at the same level, which I will be doing in a second. And 3, at the same time, drop the two objects to see which one touches the ground first. Ready?
Go.
The data is the textbook is 8.39 kilograms. The pen is 0.0097 kilograms. They both fell at the same time, and the conclusion is as follows. Our data rejected our hypothesis. Instead of the pen dropping faster, they both fell at the same rate. Even though the mass of the textbook is 8.39 kilograms and the pen is 0.0097 kilograms, they both fell at the same rate. After the interview, we concluded that you were correct. How do you feel about that?
What did I even say?
The two objects fell at the same rate. Based on our information, which is David behind the camera, you were right after our experiment. How do you feel and what are your thoughts? And how did you come to that consensus?
Well, since everything on Earth is 9.8, and without air resistance, they all hit the ground at the same time. So,
That's how you came to the consensus of they would both fall at the same time.
yes, sir.
Thank you. We have Tyler Smith here, David Williamson behind the camera. This is the follow-up interview. Tyler, after we did our experiment, we came to the conclusion that you were right, that two objects fall at the same rate. How do you feel about that?
Well, I feel very proud that Comp's work in teaching me paid off. And yeah, that's it, yeah.
How did you come to that conclusion of two objects falling at the same rate?
Well, I found out that the gravity, which is what pulls the object, is the same for all objects. So if an object has similar air resistance, let's say, so two balls maybe, they have the same structure. So it's a matter of the air resistance, really, I found, and so the gravity is the same. And also shout out to Comp for keeping me off the streets when I needed it the most.